All right, and we come to the last talk of this session and also of the day. I would like to welcome here Ganesh Shenbagaraman, I hope I pronounced it correctly, who heads the standardization of Radisys. He drives ecosystem partnerships and represents Radisys in multiple industry forums. So he's, for example, co-chair of the ORAN Working Group 8. He's also leader at 5G and FAPI standardization at the Small Cell Forum, and he is a member of the Technical Oversight Committee in ORAN, the ORAN open source community. And I would like to welcome him, and he will speak on ORAN stack reference design from specs to architecture to implementation. Please welcome.
Good afternoon, everyone. Hope you are able to hear me. Right. So, in this presentation, like Robert mentioned in the introduction, I'm probably going to talk about it from multiple viewpoints. One from the ORAN working group, stack reference design working group, representing that view, and of course the ORAN OSC view of where we are, what we are doing, and what kind of collaborations we are seeing. And I'm also part of the technical oversight committee. So a lot of things which are happening in the collaboration that's already ongoing with OAI, we're quite familiar with. And if you have any questions, do ask the questions as I present. So the agenda I had is to quickly introduce the way ORAN working group specifications are resulting in multiple different specs and what is the role of the reference design when we talk about reference design specifications and how it connects to the open source implementation or leads to the open source implementation. And a little bit of view on where we are with respect to the development, testing, and showcasing, and what are the challenges we have faced, what are the opportunities we see, and how do we see this growing and moving forward successfully. So you might have had a presentation this morning. I joined this meeting late anyway, so you might have had a presentation about all the ORAN working groups. So instead of listing all the working groups, I took a slightly different view of what is ORAN focusing on. Right from the different use cases, the architectures, architecture for different nodes and different use cases, and the interfaces, the open interfaces, the infrastructure aspects and the security aspects. And management and management and orchestration is another topic which ORAN focuses on. Service models, when we talk about the RICs, we talk about the service models, testing and integration. Right? All these topics are being worked on by different working groups and different focus groups. And the resulting publications, which are white papers, technical reports, implementation specs, reference specs, and data models, and all types of specifications, test specifications, right? So all of this is the output, and there is a whole lot of material that we publish. ORAN has been publishing, my view, specifications very furiously at a very furious pace anyway. So, and to keep pace with this through a community, it takes a lot. So, and the role of reference design specification. Originally, when ORAN was launched, there was this strong motivation to provide the reference design, both from hardware point of view and the software point of view. And especially for some of the radio unit designs, you will see very, very detailed hardware specifications from ORAN Working Group 7. And of course, there are other aspects like the compute hardware for the base station and so on. So I'm not going to deal with the hardware aspects in this presentation. It's more about the software reference design group, which I represent, WG8. So here we've been focusing on the CU and DU primarily because that forms the heart of the main processing elements of the RAN, the CU and DU. So we look at all the layer-wise implementation design and the required architecture. And of course, this is still an informative kind of specification, not a normative specification. And what we've done is gone into a higher level description of a possible reference implementation, the design aspects of it, plus a whole lot of focus on the APIs. When I say APIs, the internal modules of what constitutes a CU, DU, what are the elements of processing, some of the call flows, and gone to a certain level of detail. I'll cover some of the details in the later slide. And of course, the external interfaces and the O&M aspects also are of focus here. If I had to represent all of this work in one slide, this will be that slide. And ORAN works now based on a model called the MVP features, and right from the use case definition and the required architecture for it, the node level or the individual component level specifications and interfaces, which is typically a stage 2 detail. And the stage 3 is where you get into the protocol level, IE level details, data models, and so on. All of this combined gives you the complete specification to implement a particular feature. And what we do in Working Group 8 is translate them in adequate detail as a reference design, and mostly at an architecture component level, then some of the call flows and APIs to describe the CUDU and the supported features and functionality. And we also develop what is called an IoT specification, because the design can be implemented in different ways between CU, DU, and RU, the core elements which we are focusing on. And we have a very detailed test specification covering this through our IoT test specification. And all of this is at least finding its first or the most relevant implementation or application, I would say, in the OSC community or an OSC, of course. Anyone can follow. Our theory is that even if there is a startup who wants to start a new implementation of a RAN element, they should be able to use the reference design specification and start off that with that's the starting point, right? The design which we are given. So in the OSC releases, if you see the ODU and OC implementation should follow. Today we have only the ODU project very active, and there's no active OCU project in the ORAN OSC community, but the implementation follows the specifications reference design which we have done in WG8, and of course the test cases as well. So we do have interdependencies on different working groups specifying a particular feature, whether it's MIMO optimization or RAN slicing or ORU sharing or any such feature. And these are the MVP features, for example. And all of that is translated by our group into a reference design and an appropriate test case for that. And what we cover typically in the architecture and API documentation design is the building blocks for CU and DU. The internal modules are described in detail, and the APIs between those modules, how to implement those interfaces or internal interfaces in APIs between, let's say, RLC and MAC and different layers in layer 3 in CU. And we have done a good bit of work starting in 2019, 2020 in defining a complete set of APIs between MAC and scheduler with the view that there is a different type of, I mean, if you can plug different types of schedulers into MAC layer and then make your MAC and scheduler quite independent. And these APIs can be leveraged by anyone who wants to plug in a new type of scheduler and just see the scheduler working with the rest of the ODU implementation. And of course, we are reusing the FAPI, small scale forum FAPI interface towards the MAC and PHY hi-fi interface on the ODU. And we have a whole lot of content coming up in terms of the MVP feature-based edition and the call flows related to that. The IoT specification, this is something we started again almost in 2020. We've seen some 8 or 9 releases of this specification now. And with this, we are able to describe adequately when you build an ODU and OCU in compliance with the ORAN architecture, how are you going to test it, and the different test cases from the very basic level ones to the more advanced one. If you're, let's say, doing a cloud-based implementation of a DU and CU, how do you load and test the security-related test cases, So we have around 75 plus test cases today in this test specification, and we'll add more test cases as we go into the future releases. And of course, this is all driven by the MVP feature content in ORAN. So how this is being implemented within the ORAN software community, we have split this into 3 projects. The OCU, which is not an active project today right now, because there is no company or organization contributing to the OCU in the ORAN open source community today. Today, we are using a binary from Radisys for lab testing. And for the ODU high, we are the project lead. Radisys is the project lead. And we've been working on this particular implementation since 2019. And it has taken a lot of work in terms of maturing this and aligning to the overall ORAN specification and while being compliant to the 3GPP specs underlying. We have more effort going on in the integration side. We'll talk about it in the next slide. ODU low is another project wherein Intel is the project lead, but this is again a binary only release. There is no actual open source software development. There is no source code access. This is another peculiar thing you will find in the ORAN open source community today. So it's kind of right now kind of tied to the Intel FlexRAN architecture or the Intel FlexRAN implementation, only between the layer 1 and layer 2 level of detail. Rest of the implementation in ODU is all generic and all compliant to ORAN. So in terms of the features, we have built it from scratch so as to say like the layer-based modules, MAC, scheduler, RLC, and all the ONM modules, and different interfaces of O1, E2, and even some form of auto interface to host it on a cloud environment. And the current support is for TDD and FDD modes, and we have been using various different types of stubs before we even get to the actual end-to-end tests, right? For example, there is a 5-layer stub that we have developed to make sure that the rest of the DU code can be tested without getting into the actual integration. A rig stub to test the E2 interface, and all of these test utilities have been done. And a good amount of effort has gone in to implement a basic round-robin schedule with multi-UE support with the capability to schedule multiple UEs per TTI. And this needs to be tested end-to-end in a lab still. And the scheduler framework also includes the support for the RAN slicing framework, so that when you introduce the concept of slicing right from your CU to DU, we'll be able to support that in the scheduling with the flavor of slice as well. And all other standard 3GPP features like multi-bearer support, mobility of inter-CU, intra-CU handovers, and DRX and other features are there. This is not an exhaustive list anyway. And of course, we support the E2 interface. Right now, we are compliant with the E2 AP 0.03.00 version. And our plan is to integrate some more use cases of rig service models, and basic KPM model integration has been already done. In terms of the progress and challenges, the way we see it, we have had good success in certain areas and good community effort and I would say collaboration going on. Streamlined process of OSC, which James just talked about. We have very extensive, mature processes within the OSC community. And we have been able to clean up our code with various different tools, and the code you see is compliant with the norms of Linux Foundation. And the DU development, at least the ODU high development, I would say it is in a steady phase. When I say steady phase, we've seen more than 7 or 8 releases now, and we see a certain stability with the code and predictability of completing certain features on time as we plan, what we commit and deliver in a particular release. We do 2 releases in a year. And of course, all the alignment with the ORAN specification is ensured and guaranteed. And on the integration and testing side as well, we've been able to use the lab capabilities of both here in the US, the AT&T lab and the NTUST lab in Taiwan. And we've done some basic integrations of ODU high and ODU low. And the basic frontal integration as well has been done. And where we were stuck with issues of support and infrastructure is mainly the test equipment. So we are right now at a stage where we're about to test the the UE initial access, or we were already testing the MIPSIP part of it, but there is a discontinuity in the lab, lack of availability of the test simulators or support at the right time. Sometimes it takes support from multiple teams to get this done, and that's where we get stuck, or this is taking much, much longer, right? And so in general, our view is that we need more development bandwidth given the nature of the DU and CU software development, all the complexity that is involved in the 3GPP technology there. And we need probably a broader strategy of collaboration for developing so that we can help across the open source projects. And at least in this ORAN open source community project, we need to get to a state where we can test with multiple different PHY implementations. Right now, it's only Intel FlexTen based. And the most important element which we can emphasize as our current bottleneck is the lack of test equipment or the availability of support simultaneously. When we hit that crucial period of testing, sometimes things do not fall in place. And I believe we've been struggling with this kind of testing, or the last step of testing with the UE or the commercial UE or a UE test equipment for the last 2 releases. It has not happened well. So one of the requests through this meeting is to see or find ways and means to expedite, accelerate this. So, and of course, had a discussion with Irfan a month ago. Probably there is enough scope between OAI and ORAN open source community to make this, expedite this, right? Yeah. So that's my last slide in terms of how to leverage the capabilities of different open source projects. ORAN OSC and OAI both can accelerate the development of the key capabilities by our collaboration. And I believe we are at a stage where we can demonstrate to the industry in multiple different forums about the joint capabilities which we are having through these projects. And sharing lab infrastructure, I believe this is an important and relevant topic. Probably we'll be discussing, seeing more demos, maybe discussing more during this conference on how to do this, how to maximize this, how to optimize the level of testing which we are doing, and sharing the capabilities to make greater progress. And of course, through this meeting, I'm requesting more participation, not just in the development activities, even in the participation in the ORAN standardization activities, especially the reference design. And that is, in our view, a virtuous cycle wherein you define the spec, do the implementation, provide feedback and corrections to the specs again, and implement and test, give feedback to both the implementation and the specification. So that should be the virtuous cycle which we should be looking for. And increasing the user base and feedback loop is very, very important in our view. I'm glad that this is happening in the setting of a university, and more academic institutions, more research institutions, more companies, if they use it, and the broader it gets into use, we believe the quality of the software which we are producing and the impact of our software will be higher. That concludes my presentation.